Flatpak has won the Universal Package Management war on Linux. Or has it? In this video, we're going to be taking a look at the state of Flatpak in 2026, why you should use it over the other package managers, in my opinion, and how I like to use Flatpak. Now, let's start off with talking about why these universal packaging formats have to exist in the first place. So if we look at the old model before we had these universal package managers, basically distributions would act as vendors for all of your packages. And this is from the system to the app level. So if you are installing Debian stable, for example, you're going to be getting Debian stable packages for every single thing on your system. Now, to explain the problem with this approach, I'm going to split packages into just like two types of packages you might want to install. You're going to have your desktop platform here. So this would have like your kernel, your drivers, your desktop environment, super integrated system tools, things like that, just your desktop stack. And then you're going to have your apps. That would be your web browsers, your office suites, your games, things like that. Now, the problem with this approach is I think the majority of people, I'm not talking about like Linux users who really want to customize their system who would just use Arch. The majority of people are trying to get their work done. They want a stable desktop platform where they know that their distribution isn't going to break on an update, but they still want the latest applications and everything. The problem is with an older approach, you can't really have both at the same time. There's going to be distributions like a Debian stable or an Ubuntu LTS, which is going to give you a stable desktop platform, but they also have to use older versions of applications because these two types of packages have to share the same dependencies and libraries and things. So a newer package that may require a newer library wouldn't be able to run on this older package base. Now, on the other side of the spectrum, you have distributions like Arch Linux, which is giving you all of the bleeding edge app packages, but you're also getting a bleeding edge desktop platform, which may not be as readily tested, or if you're on a desktop like GNOME, where every single time GNOME updates, all your extensions break, that can be a problem. And so the desktop platform and the apps having to be coupled together through a distribution system has created quite a few problems in the Linux space. So starting with the rise of these universal package managers like Flatpak, Snap, AppImage, now apps do not need to be tied to the same libraries as system components do. So you can take something like a Debian stable, which is going to give you a stable based platform, and install the latest GNOME apps that use the newest version of libadwaita without worrying about compatibility issues. Additionally, this has created whole new concepts in the Linux space, such as immutable distros. So I'm building a immutable distro myself called StillOS, and what I am able to do is package the entire base desktop platform as one singular image. And when you update the system, the whole image is able to update. And this prevents any package manager dependency issues that could occur through dependency conflicts, things like that. But because there's no package manager and it's all a image-based approach, apps are all provided through Flatpak. So before we had these universal package managers, a distribution concept like that would never be possible. If you're interested more in this, check out StillOS, which will have its stable release in around a month. Don't quote me on that though. And then also check out distributions like Fedora Silverblue and some of the universal blue distributions. Now, the other problem these universal package managers are able to solve is developers don't need to work with distro vendors anymore to ship apps. So some of the problems that used to happen with the traditional model is if your app is a brand new project, it hasn't gotten any traction yet, good luck convincing a distro developer to maintain a package for your small application that just came out. Additionally, sometimes distributions do a bad job packaging packages, which can break parts of the application, which has resulted in applications like Bottles having to make a open letter to distributions to stop incorrectly packaging their apps. And they were respectfully asking distributions to not package Bottles at all and to ship the Flatpak instead. And in the future, they even added changes where Bottles won't even launch on non-sandboxed environments anymore. So these universal package managers are able to give developers a way of packaging their applications that gives the developers complete control over their app. With that, we do have a few universal package managers. Why did Flatpak become the one to win out of the three? To answer this question, let's talk about the other universal package managers first. Let's start with AppImage. So these are going to be portable applications, kind of like a portable.exe on a Windows system. So this is an AppImage for the Helium web browser. I can just right click that, go to properties, executable as program. So now if I double click it, boom, I have a full web browser being launched right here. Now, there's a couple problems with AppImages. One, there's no consistent update system. There is a project here called AppImage Update, which is made by the AppImage team. But one, you have to install this whole other project in order to just get updates working for your applications, which to me isn't viable for your average computer user who wants to be able to just get their work done and not configure their system. Additionally, not every AppImage supports it, so it's not even a full, complete solution here. Another thing is they're harder to integrate into your system. So if I launch this AppImage again here, as you can see, if I go over to my GNOME overview, it is missing an icon. It doesn't know that it's its own app. And if I want to launch it through my system launcher, I guess GNOME does let me launch the AppImage file here, but it isn't like marked as an app in your system. Now, there is a great program called GearLever that can help you fix this. So if I open it right here with GearLever, click unlock right here because I've verified that this is a legit app. Now I can just click move to the app menu. Oh, I can even update it right here too with AppImage Update. Okay. I didn't even know GearLever supported that. Now I am able to launch this through my base system and it completely acts as a normal application here. And the only downside is now you're going to have a AppImages folder in your home directory. I changed it to applications and configured GearLever to switch it to this. But that can just be annoying if you don't like your home folder cluttered. I don't care about that. But the problem is, correct me if I'm wrong in the comments, but I don't know of any mainstream distros that are shipping GearLever pre-installed. And again, you shouldn't have to expect your average computer user who just wants to get their work done to have to go out and hunt for a program to integrate their software into their system correctly. The final issue of AppImage is something called libfuse, which is a dependency for AppImages to run. And a lot of AppImages, especially older ones, depend on libfuse 2, which is no longer shipped on a lot of major distros because libfuse 3 is now a thing. And so yeah, while newer AppImages do have libfuse 3 built in, a lot of older AppImages you have to manually install libfuse 2 into your base system, which again is not something you should expect a average computer user to use. So while AppImages do work great, you still have to have some intermediate system knowledge in order to use them properly. Now, let's talk about snaps. I love using Snap on a Ubuntu server, but on desktop, they're not it. For one, this really annoys me, but snaps create tons of different loopback devices, so it's kind of became a joke in the Linux space where if you run lsblk on an Ubuntu system, you're going to be met with all of the snap loopback devices it creates. And then another thing is there's just been a lot of community rejection and community pushback for a few reasons. One, the only repository you can install snaps from is the Snap Store, which also has a proprietary backend, and there's no other Snap repositories you can get. And so people feel like Canonical is trying to force their platform on them. Ubuntu has also changed some traditional app packages, like the Chromium web browser, for example, to be transitional packages where it would automatically install the Snap version of Chromium and it would just pull that in. And these two things combined has caused downstream distributions based on Ubuntu, like Linux Mint, for example, to completely block Snapd from even being installed out of the box. And you have to run these commands in order to enable Snap on a Linux Mint system. Now, the next reason is the reason I'm not shipping Snap on my distro, because I could enable more app compatibility by shipping snaps. However, getting sandboxing working through snaps not only requires you to use AppArmor as your security system, which makes it unviable for distributions that ship SE Linux like Fedora and Red Hat and my distro because it's built on top of Red Hat. But even if you do ship Armor, you have to pull in tons of different AppArmor patches in order to even get confinement working for snaps. So Solus right here, they're saying that they maintain almost 60 AppImage patches in order to get proper snap support on Solus. It is for this reason that if we look at the distributions that pre-install Snap, Solus is one of them. They claim that Manjaro ships snaps, but if I go over to the Manjaro documentation, it says that you have to go and enable Snap by installing it and the Software Center plugin. And then every other distribution that they say pre-install snaps is Ubuntu based, so they don't have to do much work to get Snap working, but they have kind of locked out Snap from other distros just because of the maintenance burden it adds with AppArmor, which to me kind of makes snaps just an extra package manager for Ubuntu and not a true universal package manager. Additionally, I don't care what the benchmarks say. I know they have put in work to fix this, but if you just use snaps, sometimes they just feel a lot slower than their Flatpak counterpart would. Argue with me in the comments, but that's just reality. So with that, let's talk about why Flatpak ended up winning other than the issues with the other alternatives. One is KDE and GNOME are both behind the adoption of Flatpaks, and almost any application that is made by GNOME and KDE that you can think of has a Flatpak available on FlatHub. And speaking of FlatHub, this is the de facto Flatpak store. Flatpak does allow you to make other stores, and a couple distros like Elementary OS and Fedora have their own Flatpak stores, so they're not having the community backlash that Snap has. But FlatHub is the de facto store, and you're going to find almost any application you need on FlatHub. Additionally, there's tons and tons of distributions that are mainstream that either ship FlatHub out of the box or make it very easy to set up and enable Flatpak in FlatHub. So that helps make it a truly universal package format. It also ships on SteamOS, which in my opinion right now is the most important Linux distro for consumer usage because it's introducing so many people to Linux gaming. And if you're in desktop mode on SteamOS, Flatpak is your only option for installing applications because SteamOS actually fits this immutable distro structure. And like I said, nearly every application you would want is shipped as a Flatpak, with a few notable exceptions that I'll get to. Now let's talk about some of the problems with Flatpak. One, Flatpak sandboxing is security theater, and I think it may give some people a false sense of security from their applications. First off, Flatpak has a permission system, but apps are for the most part, able to just ship with whatever permissions they want pre-installed. And I bet you are not looking at the permissions that the Flatpaks you are installing are using. For example, I'm not saying Google's doing anything malicious with this, but did you know out of the box, Google Chrome can read everything in your documents folder, can read everything in your videos folder, your pictures folder, and your music folder. Again, if Chrome was doing something malicious, I don't think FlatHub would even list it, but did you know that Google Chrome was doing that? I didn't until I was making this video. Additionally, sometimes bundled dependencies can be vulnerable and overlooked by devs, so you are shifting the packaging responsibility to either a community maintainer or a developer here. And so on the older traditional method, if there's a vulnerable dependency, the base distro would update it and it would be fixed for every single app on your computer. Whereas with Flatpak, you have these app runtimes, and if the developer maintainer is not updating their apps to use these runtimes, you can have situations like this. This is OBS. Love this piece of software. It's updated frequently. I'm using it right now to record this video. But if we go over to this right here, we can actually see it's using an end-of-life runtime. So the older KDE runtime that they're using could easily be vulnerable with a vulnerable dependency, and that I could get pwned through that. I'm currently editing this video right now, and I want to point out something I missed when I was initially recording this video. But some software centers, like I'm using the Bizarre Software Center right here, they actually mark OBS as unsafe to use because of the runtime no longer being updated. Now, this is an overblown issue because the apps still are sandboxed, so I don't expect some sort of privilege execution vulnerability from happening, and the majority of apps are not accessing user-generated content from the internet. So it's not like someone's going to remotely hack my computer through using OBS, but that is a problem that can happen with Flatpaks. So I do think that the sandboxing in Flatpak is a little bit of security theater. Yes, there are technical real security benefits, but I also think it does give users a false sense of security. That said, if you're using FlatHub, all your apps are going to be curated and checked by the Flatpak team anyway, and they've seemingly done a very good job of keeping malware out of FlatHub, and you cannot say the same thing about snap packages here. However, another thing worth mentioning is the sandboxing can break things. For example, you have some apps that require you to run like a script or something to set up UDEV rules, and this tends to happen a lot with apps that need very heavy integrated system access. Another example of this is IDEs. So this is VS Codium. This is supposed to be kind of a Microsoft version of Visual Studio Code. And on the first launch of VS Codium, you get this whole documentation on how you may need to override Flatpak permissions to run X11 apps. Or if you need to execute a command on the host system from the embedded IDE terminal, you actually have to run host spawn like that. If as you can see, if I try to open ZSH, normally without using host spawn. It just doesn't work because it isn't part of the Flatpak. Although it does give you instructions on how to configure that yourself to always do that. This honestly should be something that's default on the Flatpak. And then another thing is if you need a software development kit, like something for .NET, Golang, Java, Rust, you end up having to install these free desktop SDK extensions. And then you have to modify the permissions to even use these extensions by passing in a environmental variable. Now, IDEs are a tool made for developers, so the people that these IDEs are targeting would be able to do this. But still, going back to my point I was making for AppImage, people want to just get their work done on their computer. They don't want to have to go and fix things like this. Lastly, this is super overblown by Flatpak haters. I don't think this is as big of a deal as people think. Some applications like web browsers that have to create their own sandboxing, they are forced to use the Flatpak sandboxing instead, which in the case of Chromium here is technically a weaker sandbox than the one that stock Chromium provides if you install it through a RPM or a deb package. And this is bad because web browsers do have the largest attack surface of all user-facing applications. You're going onto websites that run user-generated code, so any vulnerability in a web browser could end up with your system hacked if the web browser has a 0-day. That said, you still get some sandboxing because you're still getting the Flatpak sandboxing. It's just the sandboxing in the Flatpak version of a web browser is going to be a bit weaker. I don't think this is that big of a deal because if you just keep your web browser super up to date, you're not going to have 0 days that can happen through this. But I wouldn't want to be on a super old version of Chrome running in a Flatpak. Although I also wouldn't want to be on a super old version of Chrome in general because of all the 0 days it probably has. The last point is not every application works through Flatpak. For example, CLI apps. CLI and server apps on a technical level can work. It's just every time you want to launch it, you're going to have to type flatpak run org.organization.appname, and you can alias it, but that's just extra work. So you're not going to get a very native experience for things like CLI apps and server apps. It's also impossible to install drivers through a Flatpak because they are not that tightly integrated into your system. You still have to use a traditional package manager for that. And then it's also impossible to have applications that require super tight system integration, like a VirtualBox, for example here. This isn't possible because it requires kernel modules that Flatpak isn't able to install. And so we're not going to be having VirtualBox packaged as a Flatpak anytime soon. With that though, here's the stack that I recommend for the majority of people who want to have newer applications on a more stable distribution. Distribution for anything related to the base system, like the kernel, your system components, your desktop environment, your drivers, any super integrated system tools. And then I put the distribution for maybe IDEs because when I'm working in an IDE, I want tight system integration. It just makes it more efficient to do my work done when I don't have to think about the sandboxing. But I use Flatpak for just about everything else. And that way, my distribution that I'm working on is based on Alma Linux. I get the super stable enterprise Linux style base that I don't have to worry about breaking with an update. And on my distribution, it's immutable too. However, I also get the latest and greatest from my GNOME applications, for example. With that, if you like this video, be sure to like and subscribe. I'm trying to grow this channel again. Also, check out my video on X11's death. If you like this video, you might find that one pretty interesting. And I'll see you in the next video.